Hello everyone. Here in this video, we would like to talk about a term called something like a closed pipe. What is a closed pipe? Let me first start our discussion with that point, right? So, it's a kind of a pipe which is being shown like this. Thin pipe whose one end bottom is closed, the upper end is open. So, be careful. Closed pipe doesn't mean it is closed on both sides. It is closed at one bottom side and open at the other side, right? So it's a thin pipe. I have just only drawn the diagram to make it little large, to show you a little large, but it's actually thin pipe. So what happens when you send a sound wave into that? It transfers like a transverse wave. So transverse wave will have a kind of a crest and trough, but this is a closed pipe. Therefore, this is like a dead end. So sound cannot go beyond this point. Therefore, sound reflects back from here. So I will draw a line, I will draw a possibility. That's the least kind of possibility. So imagine a kind of a sound wave coming that will go and hit the bottom of that closed pipe here. And it has got obstacle, therefore it comes back. This is how it is coming back. So if you notice here the displacement is minimum. It's a stationary wave. Here what is formed is a node with a minimum displacement. Here the displacement is maximum. That's the formation of an antinode. So it's like a stationary wave. So if we consider this entire length of the string as L, some value, throughout the L, only two things were happened, one node and one antinode. If you remember the stationary wave, I will just draw a stationary wave for your reference. Like this. This is a node, this is also a node, and this is an antinode. If you notice, this stationary wave, a standing wave, is having a crest and then returned. If it has to become a complete wave, it has to go actually like this. If it has gone through this entire crest and trough, I could have called that length as wavelength. So but that is only between nodes and nodes, half of that. So this distance is the half of the wavelength. So you know the distance between two nodes is lambda by 2. Now I have a node and an antinode. So if you see carefully, this node and node having antinode exactly at the middle. So the distance between them is half of the distance between the nodes. Between the nodes lambda by 2, so between node and antinode lambda by 4. So what we can see is entire length of this closed pipe have a length of lambda by 4. That implies lambda equal to 4L. We know V equal to L lambda, corresponding N equal to V by lambda, but lambda equal to 4L. That is V by 4L. This is the least possible frequency that can be generated here. This kind of a frequency N1 is called fundamental frequency. Fundamental frequency. Or people also call it as first harmonic. Or people can also call it as zero overtone. Be careful. Overtone is an exaggerated way of expressing harmonic. As you have exaggerated the term name, you have to reduce the number from harmonic means first. If you want to say it in an exaggerated way, say it, but reduce the number to compensate its effect. So first harmonic is similar to that of the zero overtone, whose frequency is V by 4L. Right? That is first harmonic. That is first harmonic. So what I have drawn here is the first harmonic or zero overtone. Let me draw the next thing, that is second harmonic. How does the second harmonic forms? Let me explain. So let me consider a closed pipe, the same closed pipe, which is closed at one end. I'm drawing only a larger diagram for the visibility sake, but it's actually thin pipes. This is one mode of vibration called fundamental mode. But when sound goes and travels through that pipe, it need not travel that way. It can travel in many ways. What is the other possibility is it could actually come and hit here and hit the bottom here. And then it reverts back like this. So one thing that I want you to notice carefully is at the closed end, node. At the open end, antinode. So this is a closed end node. Here, of course, one more node is formed. Here at the open end, antinode is formed. I know the distance between node and node, as I have explained to you earlier, is lambda by 2. Between node and antinode, as I have shown earlier, this distance is lambda by 4. So the total length here is shared as lambda by 2 and lambda by 4. So 4 is an LCM, 2 lambda plus lambda, that is 3 lambda by 4. That implies lambda here is 4L by 3. Once if you got the value of lambda, we can use a formula V equal to N lambda, N equal to V by lambda. V by lambda is how much I have got? 4L by 3. That is 3V by 4L. I call this N2 as N2, frequency as N2, that's called second harmonic. So this is called second harmonic, or you can call first overtone. As I told you, overtone is an exaggerated way of saying it. Whenever you say overtone, to make it equivalent of harmonic, you have to reduce the number of harmonic by 1. So second harmonic becomes first overtone. But if you notice little carefully, you got N1 equal to V by 4L, whereas N2 equal to 3 into V by 4L. So I can write N2 as 3N1, that is second harmonic. If you have continued writing it for a third harmonic, I'm not deriving it now because we can do that now. N3 can be written like 5V by 4L. So the ratio of N1 is to N2 is to N3 is 1 is to 3 is to 5 and so on in a closed pipe. That's how we get a ratios of frequencies in a closed pipe, right? Hope you understand that. Just for the sake of observation, if you want me to draw for the how does the third harmonic looks like, I can just draw a diagram for you. Third harmonic, second harmonic I have derived. If I have to show third harmonic, see, in second harmonic, one segment and another half segment. Third harmonic means there will be two segments like this and then half segment. So node, 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 antinode. If you try to count the number of the nodes, 1, 2, 3, 4. Nodes are 4. Number of antinodes, if you try to count, 1, 2, 3. Right? So always the nodes are 1, 2, 3. Right? Okay. Now let's have a look at that. If we have to count the number of nodes, this is a node, this is a node, this is a node. So there is only 3 nodes. It's not 4. Huh? We have to count the number of antinodes. 1, 2, 3. Here are here only at one place, right? So there is the antinodes are also equal to 3. What's the length of that if we have to look, right? Node to node, lambda by 2. Node to node, lambda by 2. Node to antinode, lambda by 4. So The length of that, I'll just use a different color for it, say lambda by 2 plus lambda by 2 is lambda. Lambda plus lambda by 4, 5 lambda by 4. So lambda here there is 4L by 5. It implies n equal to V by lambda, 4L by 5. That is 5 times of N1, 5 times of V by 4L. That's what I have proved, right? So in a closed pipe, we can get the frequencies in the ratio of 1:3:5. So this is called fundamental mode, first mode, or zero overtone. This is called second harmonic or second mode of vibration or first overtone. Like that, we can talk about closed pipe. In the next video, we will talk about an open pipe. That's it.